All right, let's work on some molarity and molality practice problems. Before you start the practice problems, you need to watch the lesson video where I describe the differences between molarity and molality, and then also how to make a desired solution, a desired concentration of solution in lab. But I'm going to work a couple of practice problems on pages 182, 184, and 185 in this video. And then feel free to stop and start as needed so that you feel comfortable with the math practice here. There's also going to be the answer key up in the front of the classroom, and you're welcome to look at that to kind of work your way through what happened. But again, remember, you're going to have to be able to do this on your own, so don't just rely strictly on the key. Okay, so here we go. We are going to need a periodic table, we're going to need a calculator, and we are going to need something to write with. Now, let me zoom in a little bit. I find it really helpful for students if on the top of their paper they have what I consider to be a better form of the molarity and molality equations. And so my suggestion for you is going to be to grab a sticky note so we can write this on the top. So I'm going to go grab a sticky note and then we're going to write it together on the top. Okay, so here's our sticky note. And we're just going to remind ourselves of the two equations. So the first is molarity, and so we're going to draw our triangle. We know that molarity is capital letter M, and that is going to be liters of total solution and moles of solute. It'll always be moles of solute on the top, and we know that we can go back and forth between grams and moles of solute, but this is molarity, capital M. And then we also have molality, which is a very similar process, except for instead of being part to whole, it's part to part. So that's going to be lowercase m. This is molality. And that's going to be kilograms of solvent. So we're not looking at the whole solution anymore. We're just looking at solvent, but moles of solute. And then a couple other reminders you might want to remind yourself of is that when we're looking at kilograms, grams divided by 1,000 equals kilograms. Milliliters divided by 1,000 equals liters. And that when we're talking about water, milliliters and grams are equivalent to each other because the density of water is 1. Okay, so I would have this as a sticky note, and I would have it up on the top of my page so that I had it as a reference when I was reading through the problems. Now, we're going to use our same strategy that we always use, where we're going to circle what we want, underline what we have, and then use that to determine which equation we need to use and how we're going to use that equation. Okay, so we look at this first problem. It says I have 6 moles of MgCl2 and it's dissolved in. So if this is what is getting dissolved in, this is my solute. And in 20 liters total of water, what's the molarity? And so this is going to be my solution. And so I need to find the molarity. Well, molarity, if I cover up the M for molarity, is moles of solute divided by liters of solution. So moles of solute divided by liters of solution, I have 6 moles of solute. I can divide that by 20 liters of solution, and that gives me 0.3 molar as an answer. And we can check and see that I've got 0.3 molar as an answer. Okay, I have 3.6 moles of KOH, and it's dissolved into 18.3 liters of acetone. What is the molarity of the solution? Now I'm going to pause real quick. I'm going to apologize in that I do not love the way that these are written. They are not written very well. This should say of water solution, just like this should say of acetone solution. Because when we're finding molarity of a substance, it's of total solution. So it's okay if they tell us what the solvent is, but we need to know that it's not just that solvent, it's that solvent as a solution. And so for all of these problems, whoever wrote this worksheet, they needed to include the word solution in the problem. And so I'm just going to do that so that conceptually we understand what it's asking us for here. Okay, so back to our problem. We have 3.6 moles of KOH are dissolved into 18.3 liters. So this is our solute. This is an 18.3 liters of acetone solution. So this is our solution. And what's the molarity? Well, molarity is moles divided by liters. So 3.6 moles divided by 18.3 liters. We divide that out and we should get 0.196. Okay. Now, number 3, things get a little more tricky because now they give us 10 grams of NaCl and it's dissolved into 5 liters of water. So this is what is getting dissolved, so it's the solute. This is what it's going into, so this is our solution. And so we know that we're asking us for molarity. Molarity is moles of solute divided by liters of solution. We know the we know the liters of solution is 5 liters of solution. It tells us that in the problem. But we have 10 grams and we need that to be moles. So I can take 10.0 grams of NaCl and I need to turn that into moles. So I'm going to take Na, which is 22.990, plus Cl, which is 35.45, and I get 58.44 grams in 1 mole of NaCl. So 10 divided by 58.44 gives me, not that I don't think, 10 divided by 58.44. Okay, it does. 0.171, so 0.171 moles. Now I divide that by the 5 liters and I get 0.035 as my answer. 0.035 molar as my answer. Okay. All right, question 4. How many grams of NaCl must be added to? So how many grams of NaCl? That is the solute because it's being added to the 2 milliliters of water solution. Because again, remember they should have said solution there. And they've given us the molarity. So in this case, we're looking for molarity. So I'm going to go back up to my triangle because this one's a little bit different. And I'm going to say, okay, they have given me molarity and they've given me the solution and I'm looking for the solute. So I have molarity and I have solution. I'm looking for the solute. So I'm going to cover up the solute. I know that it's going to be molarity times liters and that'll give me moles of solute. Okay, so moles of solute is equivalent to the molarity times the liters. All right, so in the problem, I have 85.5 molarity. That's super concentrated, by the way, times, and it says 2 milliliters, and I need that to be in liters. So I know that if I take 2.0 milliliters and I divide that by 1,000, 2 divided by 1,000 is going to give me 0.002 liters. So 0.002 liters. So if I take 85.5 times 0.002, I get 0.171. And that is moles of NaCl, but they asked me for grams, so I'm going to have to do a conversion. I know that 1 mole of any compound is its grams on the periodic table. I recently solved that one. That was 58.44. So 0.171 times 58.44 gives me 9.99, which is exactly what I get there. 9.99 grams required. Okay? All right, so now we can look at a couple of molality problems. Molality we're going to be handling in a similar way, except for we're now going to be looking at solute to solvent. These problems are probably written better because that's how the previous problems were written. All right, so it says determine the molality. I'm looking for molality. I know that's lowercase m of 5 moles of NaCl going into 620 grams of water. So this is my solute. This is my solvent because my solute goes into my solvent. And I'm looking for molality. So if I cover up molality, I know that it's moles of solute divided by kilograms of solvent. So moles of solute divided by kilograms of solvent. I have moles of solute, that's 5 moles. And I currently have 620 grams. I need that to be in kilograms. So I know that if I divide that by 1,000, I'll get 0.62 kilograms. 0.62 kilograms. And so if I take 5 divided by 0.62, I'm going to get, this should be an 8. 8.605 molar as my answer. 8.065, which really is going to round to about 8 molal as an answer. Okay, last problem on this page. how many moles, so it's asking me for moles, of 2-butanol must be dissolved. Okay, so if it's being dissolved, it's the solute. In 0.125 kilograms of ethanol, it's going into that, so that's the solvent. If my solution has a concentration of 12.0 molal. All right, so they're asking me for moles of solute. Moles of solute is what I'm looking for, so I'm going to cover that up. And so I can see that it's going to be molality times kilograms of solvent, molality times kilograms of solvent. I have a molality of 12.0 molal times kilograms. It's already in kilograms for me. So I'm just going to multiply those two together. So if I take 12 times 0.125, I get 1.5 moles. And I didn't have to do any more conversion because it just asked me for moles. And so I would need that much of the solvent. Okay, so that's page 182. Now we're going to be working on page 184. And we're going to be doing pretty much the same thing. I'm actually going to just use my sticky note and transfer it over because it's going to be the same amount of information. Notice you've got the answer key. I'm going to do like 2 from each section, maybe, and then we're going to call it a day from there. Okay. So let's look at question number 8. Question number 8 says, how many grams of magnesium chloride, MgCl2, are contained in 0.5 liters of a 1.5 molal solution? So they're asking us for grams of MgCl2, and it says are contained in. So this must be solute because this is my total solution, and this is my molality. So they're asking me for solute. Well, I know that solute is going to be what I'm looking for on the top of my triangle. I can see from my problem that I have capital letter M, so I'm going to be using my molarity equation, and I'm going to be covering up solute. So if I cover up solute, it's molarity, capital M, times liters of solution. So I know that I need molarity times liters of solution. So my molarity is 1.5. I'm going to multiply that by 0.50 liters, and when I multiply those two things out, I get 1.5 times 0.5 gives me 0.75 moles, but they asked me for grams. And so I'm going to say, all right, well, if this is MgCl2 and I need to turn this into grams, moles to grams. 1 mole is going to equal the grams of MgCl2 on the periodic table. So 35.45 times 2, which is what Cl is, plus 24.305 is 95.21. So 95.21 times 0.75 gives me about 71, looks like I have about 2 significant digits, 71 grams. Then if I check my answer key over here on the side, 71 grams is what I get. Okay, just a couple of notes as you go through here. Remember that milliliters is going to have to be converted to liters by dividing by 1,000. And if we ever have grams of solute, we first have to turn that into moles, or if they ask us for grams of solute, they have to turn this into moles. Volume is liters, okay? And we've got an answer key over here on the side. You're also welcome to go up and check the answer key with the sub. I will work all these problems out. So if there's an error in the printed answer key, you'll be able to check that up there with the sub. Okay. If we look at the bottom, this is molality, or lowercase m. We're going to do the same process, except for now we're going to be using our molality triangle. And I'm going to solve problem number 18 for this one. All right, let me slide down here. Okay, so problem number 18 says, how much water, solvent, so they tell me right now I'm looking for solvent, should be added to 5 grams of KCl, so that must be my solute, to prepare a 0.5 molal solution. And so they tell me that they're asking me for solvent. So in order to find solvent, I'm going to take moles of solute divided by the molality. So moles of solute divided by the molality. All right, so I have 5 grams of KCl. That's not moles. So I'm going to have to first turn that into moles. I know that the grams of anything is, or 1 mole of anything is equivalent to its grams on the periodic table. So Cl is 35.45 plus K, which is 39.908, and I get 75.4 grams. So 5 divided by 75.4 gives me 0.0663 moles. Remember, I don't really like to round until I'm done with my problem. So my moles of solute is 0.0663. And I'm going to divide that by the molality, which they told me was 0.5. So if I take that and divide that by 0.5, I get about, my calculations give me 1.33 kilograms, which is pretty close to what they get there in their answer key. So I'm comfortable with that. All right, so you can check your answer key up at the top if you need to. We're now going to look on page 185, and we're going to practice writing, how to write out a process for finding or making a solution. Remember, when we're making a solution of a desired molarity, we're going to solve for moles. Once we have moles, turn it into grams, and then we write the sentence saying we put that many grams in a beaker, and then we're going to dilute up to or add water up to whatever the desired volume is. This one is a little bit tricky because I'm going to have you check charges as you go to write this. So I'm actually going to work problem number 13 for you. Problem 13 tells me that I have 45 milliliters of a 12 molal solution, and they want to know, how do I make that of sodium carbonate? Okay, so first thing I'm going to do is I'm going to figure out what sodium carbonate is. Sodium is Na, and it has a +1 charge. Carbonate is on the back of my periodic table. It's CO3. It has a -2 charge. So if I have charges of 1 and 2, I need a ratio of 2 to 1. So I actually have Na2CO3 is my compound. Okay, so that's what I'm looking for. How many grams of Na2CO3 do I need? So for any of them that we have a name for, you need to check their charges and flip their ratio so that you can do these problems correctly. All right, so I have 45 milliliters, and I know that if I take 45 milliliters and divide it by 1,000, I'll get 0.045 liters. Okay, so in order to get the moles, I need the molarity, so 0.12 molal times the amount of liters, 0.45 liters. And so if I take 0.12 times 0.045, 0.12 times 0.045, I get 0.000648, 0.0000648. Moles of Na2CO3. But I can't measure moles in lab, so I need to turn that into grams. I know that 1 mole is going to be equal to the grams of Na2CO3. So I'm going to find out the mass of Na2CO3. That's going to be 3 oxygens plus a carbon plus Na, which is 22.990, but I've got 2 of them, so I'm going to say that's times 2. So I get 105.99. All right, so 105.99 times 0.000648 gives me, I need about 0.07 grams of Na2CO3. I'm going to put that in a beaker. And then I'm going to add water up to, and what do I need to go up to? The 45 milliliter mark. And that is my actual answer for this problem. Okay. 45 divided by 1,000 gave me 0.045. I multiplied that by my molarity. Oh, hold on, something went wrong there. 0.12 times 0.045. Okay, yeah, something went wrong here. This value is wrong. 0.0054. 0.0054 times 105.99. This gives me a better answer. Is 0.57. So apologize for that, 0.57 grams of Na2CO3 in the beaker, and then add up. And so that's what I would do for all of these problems. Note, problem number 14 was kind of hard to read. I made that read 250 milliliters of a 0.75 molar. It's lithium nitrite, so you're going to have to look up those things on the periodic table. All of these compounds, if they're not given to you, are actually polyatomic, so you're going to find the second half of that on the back of your periodic table. Okay, so that's how we practice making solutions. And you can check your answer key at any point that you need to.